Before we mentioned that word embedding plays a very important role in many natural language processing problems. So also when we learn the embedding for the words, we also need to have some task, right, to be studied for learning the embedding vectors, or we have some constraint to be cast on the learning process for the embedding vectors of the words, right? So in the following part, we can take the word prediction as a application task for studying the word embedding problem, and we can briefly mention what is word prediction and how to apply them to study this word embedding problem. So in this page, we show you with the example. We have some sentences, however, we also mask some of the words in these sentences. Like inside this document, we have some sentences, the curtain open and some words shining in the balcony. And then we can have another sentence and the code close something, and these are something others, right? You can see we have something masking, right? Also surrounding the masking words, we also have some words which are highlighted, right? Like shining, brightly, night, cold, night, bright, seasons, temple, dark, shape, sun, shiny, duke, star, moon, trees, rise, something like that, right? You can see, these words can provide us with some signals or hints to infer the missing words. And if we think in this way, these missing words can be inferred by this context, right? This is one way to think in the problem, right? We can infer this missing word by the context. Another thing is probably we can also infer the context by the missing word as well, right? In other words, according to the missing word, we can also infer the potential words surrounding it. This is another way of thinking, right? So from the words which are nearby the missing word, we can define highlighted words as the context of the missing word, before it and after it as the context for the missing word. So actually, according to the highlighted words, we find that this word is probably correlated with shining, with night, right, and cold, and sun, and also some other words like moon, right, for example. Actually, if we remove this hidden block here, we find that the missing word we are predicting are all the stars. We have stars shining, right? And all the bright stars, and stars that rise, and shining stars, and star all the moon, something like that, right? We find that all the highlighted words, they are correlated with stars. At the same time, these stars can also be applied to use infer probably the nearby surrounding words as well, right? There are different ways of thinking. We can discuss more about the way, either infer the surrounding context based on the missing word, or infer the missing words according to the surrounding context in these two different ways. You can define two different models. The first one is Seibao, the second one is called skipgram. These two different models. They work very similar, however, in different directions. Okay, so when we do the prediction of some missing words, then we are starting the word prediction problem, according to the surrounding context of the words. And here, if we first extract the surrounding context words out, and actually we find that some of the words will appear more frequently than the others, right? So for example, if we plan to learn the representation of the words, one of the many ways to define the representation of the word is probably by extracting some frequent words which are nearby or which appears very frequently in the surrounding context of the target words. For example, according to the previous page for the stars word, by extracting some frequent words appearing very often in the surrounding context, we can define this representation of this stars word manually by defining it as a vector, something like this. Because according to some data, we have the shining may appear very frequently, 38 times. Bright also appears very frequently, like 45 times. Then tree appears 2 times, dark 27 times, and look 12 times. We can extract these frequent words to define the representation for the words. This is a way we can define the representation manually, right, by extracting these frequent words. Actually, these frequent words we extract here can also illustrate the physical meanings of the word star as well, because according to the representation we extract manually by using these frequent words, we find that this star will also be very similar to sun, right, according to the location in the feature space compared with some other words like cucumber. So according to the context, we can extract some useful information about the word. Then we must consider if we can learn the representation of some words by using its context, by using its nearby context in the documents. So we can briefly mention how to do the word embedding representation by starting this word prediction problem. So we need to introduce a very important method. It's called word to vector. In the word to vector, we have the inputs, also we have the desired outputs, right? So the input we have a sequence of words from a vocabulary. We have the word sequences, which will be very similar to a sentence or documents. And we also have one predefined vocabulary set, like V as shown here. The main target we are studying for the word vector or the word embedding problem is to learn a mapping to project the words in the vocabulary set into a feature space of dimension D. In other words, for each word in the vocabulary set, we want to learn its embedding vector. The embedding vector, the size or the length will be has D different entries. The output will be a fixed length vector for each word in the vocabulary set. For example, the word W from the vocabulary set, we can learn its embedding as V vector. The size is D, right? So this is the word embedding problem we are studying, or the word to vector problem we are studying. Actually, we can start this problem based on this word prediction task we showed before. Then, by predicting the missing word, we can construct a model to embed the words into some embedding vectors. We will show later. So in the following part, we can introduce two different methods which can be used to learn the embedding of the words, and which can also be further used to predict the missing words as well. So the first method we will discuss later is called CBOW, or continuous backward words. It can predict the current word using the surrounding context. This is a very normal way, right? We can predict the current word, the missing word, by using the surrounding context. Then in this way, we can learn the embedding vectors for all the words in the vocabulary set. Or we can do the prediction, with this skip-graph method, we try to predict the surrounding context using the current word or the missing word instead. This is another way of thinking, right? We have mentioned this already in the previous page. So this CBOW and skip-graph, they work very similar, however in different directions. This one is to predict the current word by using surrounding context. This one is to predict surrounding context using the current word instead. Both of them can be serving as a method for learning the embeddings of the words. They can also be used to study the prediction task of the words as well. In the following pages, we can discuss the two methods in detail for you instead.